Here's a solution to some aspects of practice question 5 from the week 2 questions. Part A of question 5 asks us for the probability of Z being greater than 2. Z is the symbol which is generally used for the standard normal distribution, and the standard normal distribution is a symmetrical bell-shaped distribution since it's normal. Its mean is 0, its centre, and it has a variance and also a standard deviation of 1. One standard deviation either side of the mean. The normal distribution has its points of inflection, so that's there and there, and then within 3 standard deviations either side of the mean, so second, third, -2, -3. Within that range between -3 and 3 standard deviations either side of the mean, more than 99% of the observable values of Z occur. In this question we're asked for the probability of Z being greater than 2, so there is 2 and we want to find that area. That area is the probability of Z being greater than 2. Sorry, and along this axis we're actually measuring Z. So what Excel function should we use to do this? Well, there was a handout in class which should help with this. And seeing as we're dealing with a standard normal distribution, we should be at the bottom of the first page considering between these two functions. In this case we know a Z value, we're trying to find a probability, so it's this one that we're wanting to use. The only catch to just be aware of is that this function, when we give it a Z value, will give us the probability of getting a Z score less than that value. We actually want the complement of that. But we can easily find it by just putting in the value of Z that we know, 2, finding the probability of getting a Z score less than 2, and then subtracting that away from 1. We can subtract it away from 1 because the total area under the curve is 1. So this red area, shaded area, plus this area here sum to 1. So to finish off this question, what we're going to do is use this function. So we will say norm, in Excel we will type equals norm S for standard dist. We'll feed it the value 2. That will give us this area. And then we actually want that area. To get it, we would then just have an answer equals 1, take whatever the result was above there. And I am coming up with an answer for this one in Excel of 0.02275. The Excel solutions will be available for you to look at the formulas via Blackboard. So part B is, we're told this, X, a random variable, is distributed as the T distribution with this subscript 29. The 29 is the number of degrees of freedom for the T distribution. The next question that we're asked is, what is the probability that this random variable X is greater than 2? This is a very similar question to the one before because the T distribution is very similar to the standard normal distribution. It too has a mean of 0. Its standard deviation is a little bit higher than the standard normal distribution, but not that much. So it's reasonable to draw this T distribution in a very similar way, with most of the observations being within 3 standard deviations of the mean. So what is the probability of T being greater than 2? That's what we're interested in. Well, it's actually X, which is distributed as T, so that area. To do this, we'd have to again decide what Excel function we should be using, and our options here are shown on the second page of the handout from class. This one here looks like exactly what we're after. And in this case, I might just talk you through it rather than writing it down on a separate piece of paper. So we want to use equals t dist. X is 2 in this case. The degrees of freedom is the parameter that we've already seen, 29. And the tails, well, we want Excel to give us an answer where the probability is confined to just one tail, so we'll put in 1 here. And the answer that I am getting by doing that is 0.027472. And you'll see the formula in Excel. Notice that this value is just a little bit bigger than the value that we calculated for the Z distribution, and that's because the t distribution is very similar to Z, but just a little bit more spread out. So that means that above 2 there's just a little bit more probability in the tail. Okay, part 3 of this question says, what is the probability of x being greater than or equal to 2? Well, the answer is still that, because for a continuous distribution like this one, the probability of getting any particular x value is taken to be 0. So these two things are equivalent in the context of a continuous distribution. The final question says, and this is part 4 of B that I'm talking about, what is the 90th percentile for x? This is equivalent to saying the probability of x being less than some value that we don't know is equal to 0.9. That 0.9 being the decimal version of 90%. How do we calculate that? Well, if I go back to the formula sheet, in this case we know a probability, 90%, and we're wanting to go back from that to a particular t value. And in this case the function that we're going to need is this one here, t_inv. We have to tell it a relevant probability and the degrees of freedom, and it will give us an x value. But you have to be mindful that the probability that it wants is a two-tailed probability, so it actually wants to know the total area, which is equivalent to the total probability, in these two tails. Now, if you think about it, we're wanting to know a value here, x, where there's 90% or 0.9 less than it. That means then that we're looking for a value where there's 10% or 0.1 above it. And if there's 10% here, because of the symmetry of this t distribution, there would also be 10% in this left tail, that being x scores that are less than the opposite of this one. So the upshot of all this is that when we use this t_in function to answer this question, we're going to have to say equals t_inv. The probability that we want to know is, in fact, or that we have to give Excel is 0.2. So that is, to repeat, we're interested in an x value with 0.9 back here. That means 0.1 above, but Excel wants to know a two-tailed probability for that x value, which would be this plus the corresponding amount on the other side. So this is the 0.1 down here times two tails of that same amount. The degrees of freedom is 29, and when you put that into Excel, you should get an answer of something like this. So that x value is about 1.3. And I might just break up this video and talk about part C in a separate video shortly.